Friends, this question from CSD Computer System Design Quiz 1 October 27, 2024. So there is a circuit diagram given. What is the output of the above circuit? X is the input, this is the input, X is the input to the gate and Y is the output of the gate. So this is a chain of connected XOR gates. So XOR or XOR gates. XOR gates. Okay, XOR or XOR gates. So here this is the input bus. So in this point the input is X. Here also input is X. That is same input is given. That is XX. Same input is given to the XOR gate. And the same input X it will be given here also. This is the input and this is connected to the XOR gate 1, for example 2 and 3, and this is the final is XNOR gate. Final is here the bubble represents the NOT. So XOR plus NOT gate gives the XNOR gate. So this final one is XNOR gate. So all these are XOR gates. 1, 2, 3 are XOR gates. So no, 1, 2, 3 are XOR gates or XOR gates. Okay, the same input X is given here. This is also bus, connected bus, input bus. So this is given to here. So the output of the first XOR gate is given to the next input to the another XOR gate number 2. So how to solve this question? This one is very easy, friends. So how the XOR gate, truth table of the XOR gate, that is truth table TT. So how the XOR gates works? For example, there are two inputs and the output is Y. For an XOR gate, there are two inputs. How they represent the XOR gate? So this is the output Y and the XOR gate inputs are A and B. If the inputs of XOR gates are 0, 0, 0, 1, 1, 0 and 1, 1. So for this the output is 0. For these values the output is 1. So you can remember the truth table of XOR gate. It will be very easy to solve. So that is for the same input for the XOR gate. So that is A equals to B. A equals to B equals to 0 or A equals to B equals to 1. For both our inputs are same, A0 and B0 or A1 or B1. For this the output is 0. Y equals to 0. And the other values, for other values, A equals to 0 and A equals to 0 and B equals to 1, the output is 1, and A equals to 1, B equals to 0, the output is 1. So if you know the truth table of the XOR gate, it will be very easy to solve in 5 minutes. So next one is XNOR gate also. XNOR. For the XNOR gate operation, so for example A and B are the inputs 0, 0, 0, 1, 1, 0, 1, 1. Why we are considering only two inputs? Because in the circuit diagram they mentioned there are only two inputs, right? Every gate has two inputs. If more than one input, you consider C also. And there are two inputs. In two inputs, how we write these combinations? That is two inputs, right? A and B are both are two inputs. The inputs are 2. That is 2 power 2. Binary, right? 1 and 0 are binary numbers. 1 and 0 are binary. So how we represent binary means base 2. So base 2, that is 2 square. That is 4 combinations are possible. 4 combinations. That 4 combinations are this one. 0, 0, 0, 1, 1, 0, 1, 1. These 4 are combinations. So for this 4 combination only, that's why, because there are 2 inputs, we consider only 4 combination. If there are 3 inputs A, B, C, for the each gate has 3 inputs, you consider 2 cube, 2 power 4, that is 8. So Y2, 2 is the base B, base binary. For base 2, so for binary numbers base is 2. Okay. For XNOR gate, that is the for XOR gate. What is the output? XNOR gate, it is the NOT operation of the so first we write the XOR gate. First we write the XOR gate operation. This is 0 for the same inputs. XOR gate output is 0. For the XNOR gate, that is the NOT of the XNOR gate, that is NOT of this XOR gate operation, NOT of this, that is NOT of 0 is 1, so NOT gate of 0 is 1, for this 0, NOT gate of 1 is 0. Okay, this is the XNOR gate output, this is the XOR gate output. Okay, now we solve this question. Okay, first clear this. Okay, so if we know this table, truth table, we solve. So for example, here the first XNOR gate, this is the first XNOR gate, so X is input, X is also input. So both the for the XOR gate truth table, both the inputs are same, that is both inputs are same, right? X. If the gate both inputs are same, the output is 0. XOR gate output is 0, so this value is 0. So the output from the XOR gate 1 is 0. This is gate 2 and this is gate 3, and again X is passed here to the next gate, next XOR gate input, X 0. So if one of the input is 0, so 0 XOR with X value. So 0 XOR with if 1, that implies if X equals to 1, right? We put this, we put X equals to 1 and X equals to 0, and 0 XOR with 0 if X equals to 0. Okay, so 0 XOR with 1, what is the output of the XOR gate? 1, so that is 1. Y equal to output equals to 1. Here y equals to 0 XOR with 0, output is 0, so y equals to 0. So that is output values are same as X values, right? Same as X values. So output y equals to X, that is, so 0 XOR with X equals to X. You understood? So we consider this one 0 XOR with X. Why we consider? So the first gate output is 0 and the second input to the second gate is X. So both the operation 0 XOR with X. So the resultant is, so for example the result is y2, so the y2 is X only. So we calculated here 0 XOR with X, so y2 equals to X. Y2 equal to X. So this output of the XOR gate 2 is X. So X XOR with X equals to, again X XOR with X. If both the inputs are same, the output is 0. Again 0. Right? Again the output is 0 because both the inputs are for the XOR gate 3 is 0. Next here the same input X is passed here. So here 0 XNOR with X. Here the output, final output Y is, here the operation is different, XNOR gate. XNOR, not XOR gate. Here the operation is XNOR gate. So for the XNOR gate, we want to calculate 0 XNOR, that is 0 XNOR with X. That is X equals to 1, X equals to 0. That is 0 XOR with 1, 0 XNOR with 0. If 0 XNOR with 1 is, that is 0 1. That is, for the XNOR operation, the output is 0. So 0. 0 XNOR with 0. So this one, 0 XNOR with 0, output is 1. For the same input, XNOR gate, same input for A and B, for the same input, output Y equals to 1. It is opposite to XOR gate. So that is here X equals to 1. So in this equation, X equal to 1, Y equals to, so this value, right, Y equals to, so these values are Y. We calculated Y equals to 0 XNOR with 1, Y equals to 0 XOR with 0. This one, Y equals to 0 XNOR operation with X. We consider the two different values for X because it is binary. There are two values. So for X equals to 1, X equals to 0, how the Y value? Okay. So Y equals to 0, and for X equals to 0, Y equals to 1. So that is, so represent the output Y in terms of X. In terms of X, Y, because the options has X bar 1 and 0. The final output of the entire circuit diagram is Y, right? So Y here given. So Y, so the output Y equals to, right, Y in this box, X equals to 0, Y equals to 1, right? So X equal to 1, Y equals to 0. That is, both are complement to each other, right? So Y equals to, so X bar. So the final output is X bar. The circuit diagram, the final output is X bar in this circuit diagram. So friends, don't confuse here. So the final output is Y. Okay. After, so here don't confuse, this Y is the output of the second XOR gate. So this one, that is Y2. So that is, we represent Y2. It is better to represent Y2. So Y2 equals to 1 and Y2 equals to 0. So that is, if X equals to 1, Y2 equals to 1, X equal to 0, Y2 equals to 0. That is, X is same as Y2, right? The output of the second XOR gate equal to second output XOR gate is X. The output of the Y is asked in the question. Answer is this one. Option B is the correct. So option B, that is X bar. X bar for this question. Friends, if you like my videos, please like and subscribe my channel. Thank you for watching.